Hi, in this slide we are going to talk about BGP attributes. So, what are BGP attributes used for? BGP attributes are basically same like we have in other protocols, matrix, cost in OSPF for path selection. So in case of BGP, we have path attributes. Now these path attributes are not only used for path selection, but they are also used to filter the paths. For example, you don't want your traffic to be traversing a certain AS number. You don't want your traffic to go through AS 800, for example. And also, let's say you have two uplinks for your network and you don't want your traffic to be going to one of the specific uplink because it's expensive. So you can also defer some routes using the BGP attributes. Now we will be looking into these details in these slides and next coming slides. So let's first talk about the types of BGP attributes. Now, there are many BGP attributes, and they are being classified as well-known attributes and optional. Basically, there are four types: well-known mandatory, well-known discretionary, optional transitive, and optional non-transitive. Now, let me explain what well-known means. Like those attributes which are known by all the BGP speaking routers in the world are known as well-known attributes. Now, mandatory, well-known mandatory are the attributes which are basically present in all the BGP updates. So like in every update, well-known mandatory attributes must be present. Well-known discretionary are those which may or may not be present. Like it's not necessary for them to be present in every update, but they are well known. By well known means like all BGP routers knows what that attribute means. Optional. Optional are those attributes which like some BGP speakers don't know what those attributes are. So those are optional attributes. So optionals, there are two types of optionals. Optional transitive are those which once the BGP speaking router receives it, it is going to transit it to the neighboring routers. Non-transitive means that it is not going to transit it to the neighboring routers. So we have four types: well-known mandatory, well-known discretionary, optional transitive, and optional non-transitive. So let's look into all these list of BGP attributes. So here is a big list, and let's look at this: the origin, AS path, Nexthop. These are the updates which are well-known mandatory. So these must be present in all the BGP updates. MED is optional non-transitive. So this means like it does not need to be known by all the router implementation, as this is optional. And non-transitive means like once it's received by a router, like it's non-transitive. Then local preference is well known and discretionary. So what will happen is like local preference is known by all the implementation of BGP, but it does not need to be present in each and every update. So here is a list of all the attributes. What we are going to do is like in next slides, we are going to discuss each of them one by one. So let's start from BGP attribute origin. Now, origin is well-known mandatory. So each and every update of BGP must have this attribute with it, which is origin attribute. Okay, now this origin attribute has three different types of values: either IGP, EGP, or incomplete. Now let's look into it. Like I have a router over here. I will just quickly show. Okay, yeah, here it is. Show IP BGP. So if we look the show IP BGP output, what we are going to see is like origin codes over here. So I stands for IGP, E for EGP protocol, and question marks is incomplete, which means when the route is coming from some different protocol, meaning to say it's being redistributed. So we see over here the first one, I'm learning it. Both of these I'm learning from the same Nexthop, means from the same router. And we see over here that the first one is I, means like it's IGP, and the second one is question mark, which means the origin is unknown, incomplete, or redistributed. So let's look into the next path attribute. Now the next one we have, okay, here is the same output over here. Let's look into the next attribute, which is AS path. Now AS path is basically a string of AS numbers. So this is the string of AS numbers. All those AS from which this update has been passed is added into this string, is appended into it. So it's the shortest AS path is preferred, like we are receiving same update from two different Nexthops, then the one which is shorter is going to be preferred. Now AS path is a well-known mandatory attribute, so it must be present in all the updates. It grows from right to left. So over here, if we look at this, this is the path. Path means actually AS path over here, and it is going to grow because I have only 2 autonomous system in this network, so it's coming from 200 only. But let's say if it was coming from some another AS before 200, so that should be written over here like 300, then 200. So it grows from right to left, and the left is the like this 200 is the latest, and the origin is on the rightmost. Then next is Nexthop. Now the Nexthop is also well-known mandatory attribute, and here is the Nexthop. Nexthop 10.112 is the Nexthop. That's it means in the Nexthop which it needs to take to go to the destination. Now the next attribute that we would like to discuss over here is MED, multi-exit discriminator. Now this one is optional, and we see over here when we do the show IP BGP, this one is metric. Metric is the MED values. Obviously the higher the metric, it's less preferred. So it's just like the metric in other protocols that we have seen before. Now the next one is local preference. Yeah, so the local preference is also a well-known attribute, and the higher value is preferred. The default value is 100. So in my lab I haven't changed the local preference, so it should be 100. So it's not showing. There is another way of checking it. Let's do like 100.2.2.21, and let's look into it. So it tells over here local preference is 100, and that's the default value. So what we have to do is like the local preference is actually set in the inbound direction. Like once we receive the prefix from the neighboring router, so on the inbound direction we can set the local preference. Local preference, as the name specifies local, it's local to the autonomous system only. So I cannot set local preference for the prefixes which I'm sending to the neighboring autonomous system. So this is all what I want to discuss in this slide. I wanted to split into 2 parts. So the other BGP attributes I'm going to discuss in my next slides.